Cup of Go for Monday, March 13, 2023. Keep up to date with the important happenings in the Go community in just 15 minutes per week. I am your co-host, Jonathan Hall.
And I am your other co-host, recently promoted to host, recently promoted to chief host of operations, Shai Nachman. We're still trying to figure out the titles in the podcast. If we do good work, Jonathan might promote me even more.
I don't know. Do I have that power? I'm only a host or a co-host.
Oh, maybe it's the other way around now. Well, you better give me some good episode with some good news. Let's get down to it. What has been released recently?
First news this week is there are new releases of Go 120 and 119. So if you're not keeping up, make sure you update to Go 120.2 or Go 1.19.7. These are security fixes. They fix a security vulnerability in the cryptoelliptic package, which I don't know if I've ever actually directly depended on that, but I still would feel more comfortable upgrading my versions of Go to make sure that I'm running the latest.
And if you haven't upgraded to Go 120 already, we did it at work. It works fine. Just go do it. On the subject of releases, there's been a release with goreleaser. You know, imagine the meme in your head, yo dog, I heard you like releases, so we put a release note in your releases so you can talk about releases in your release section of your podcast. So if you don't know about goreleaser, it's a very useful tool, I would say, that helps you release your Go things to brew and to, update GitHub and do all the chores of building a Go binary and releasing it. So if you have a Go tool that you want other people to use, you should probably start using goreleaser to do it. It works really fast and really easy, and also has nice output, which at least for me counts. Works on your machine and on CI systems. And the recent release they put out, I think it's 1.16. Yeah, 1.16.0 has a few new features, has a few bug fixes, quite a lot of different stuff, all maintained by the main maintainer of the project, Carlos Alexandro Becker. One feature that I'm excited about is that they added Open Collective. So if you use Open Collective to, manage your community and maybe do some fundraising and stuff like that, and there are some really great communities out there, Babel.js, and I want to specifically shout out Women Who Code. If you have software releases relating to your community, now you can use goreleaser to announce directly to Open Collective when you release a new version.
Moving on to proposals, this week a proposal was accepted to add a testing bool function to the testing package. This has been a long time request, or at least complaint. I've heard a lot of people talk about on Stack Overflow and at meetups, and I wish there was some way to know if I was running a test. Well, now there will be. You can call testing.Testing, and it will return true if your code is executed by running the go test command, or false if it's executed by running either go build or go run. I'm curious what you think about this, Shai, because I have my strong opinion, but I'm curious what you think.
So, first of all, if it was accepted, then I think it's good enough, but I do think it's controversial. Like, there are a lot of ways to mess things up with this feature. I'm very scared of what people will actually use it for versus, the original intent. You could start having only test time asserts inside your code instead of actually thinking about the architecture and injecting stuff correctly into your components and passing, stuff via constructors or like new functions or whatever. You could just be like, oh, if testing.Testing, then in my production code, I'm going to shove like a const here to make sure that to quote unquote mock the response, which I think is very unhealthy.
Yes. So in the discussion, which I actually spent a fair amount of time reading the discussion, it is interesting. And they did come up with some really valid use cases that really couldn't be solved any other way, and some in the standard library. So there's a strong case for this, but I completely agree. It's a huge foot gun. I can see a lot of people. I mean, I fight a lot with people trying to put magical environment variables in their thing. If in production, then do this, and if in staging, then do this completely other thing, which if your staging and production environments aren't the same, it's not really a staging environment. So I see a lot of potential for that sort of dangerous pattern happening. Use it responsibly, please.
Yeah, and I just think that it's so easy to correctly architecture your program in Go, since it's so verbose and so simple. then it's worth taking the 5 minutes extra effort to like define an interface and define the new function and, you know, use mockery to auto-generate a mock that can do everything instead of, this is the simple thing, instead of doing the easy thing, which is just, you know, reaching your hand into the code and dropping an if testing.Testing inside your production code. Seems like it would be bad.
That's right.
On the flip side, you know, I work at a company that has a lot of sensitive data, right? API tokens and emails and whatever, and using production data within testing code might happen, right? People might accidentally connect to the wrong DB, to the wrong third-party service, to the wrong whatever, especially for writes. So checking that in the testing code, like checking that you're not in testing code in super critical paths could be a really useful middleware, right? You could say some APIs I don't even want to test. Like if you're calling this API, I just want to quit out of it if you're inside testing, because this file never should be used from testing, or this API should never be used from testing. So I can see very, you know, the other way around, where you could protect your environments from someone accidentally running a test and deleting the entire production database. You know, you're just not allowed to call drop database in testing.
Yeah.
But this is not a discussion. This has been accepted. So if you want to go implement a food gun and then have everybody opening tickets in your name for all the bugs that you've created, now is your chance for fame or infamy.
What else do we have in the world of proposals?
So there's one that's, I think everybody can agree is useful and it's not controversial at all. It's a new proposal, so you can go drop in your 2 cents. But I assume it's going to be accepted really quickly. Which is, you know, where you have a tools.go file, and whenever you open like VS Code or whatever you use to edit your project, you're like, what's tools.go? And then you open it, it's like, oh, all the imports thing, whatever. And then you go work on your actual project. So it's replacing it with a Go mod, a place where you look even less, but it actually includes the build dependencies, so it makes a lot of sense. And I think right now the proposal is just to add a dependency that has a / tool marker at the end. So you know this is a build thing and not a direct or indirect dependency for the binary itself. Just when you build it, you need it. For stuff like mockery, for stuff like generation of any like microgen and all these auto generation tools, you need them in your build when you run Go build.
I think it's a great one. I hope they accept it.
Yeah, I think there are some implementation limitations there where sometimes you do need a few of the structs of the library outside of the build pipeline as well. And then maybe if you mark it as a tool and not as a real dependency, it won't work. Like, I don't think it's as straightforward to implement as it sounds, but definitely a good suggestion, and will clean up some projects. And the final proposal?
Yeah, so we've already talked about it several times, but the new version of the opt-in transparent telemetry is now an official proposal. It had just been a blog post in sort of discussion. It is now an official proposal, so if you have something constructive to add to the conversation, be sure to head over to the issue. Their ears are open to suggestions and discussion. That's what the whole proposal process is for.
Cool. So I think this has been a very good movement in the telemetry discussion, but the telemetry discussion is going to go on for a while. We're going to keep you updated as to where it goes and where it ends up in the end. Moving on from proposals, ngrok has released a really, really useful feature, like a package, ngrok-go. If you don't know what ngrok is, it's if you've ever had to publish something on the web, like a server, a backend server, and you don't want to go through setting up a whole thing. For example, you're testing a Slack bot locally, and you just want to develop it and make it talk to Slack like for the next 5 hours, and not something super permanent. ngrok has been very useful. You know, one of the knives on my Swiss Army knife, where I can just ngrok whatever, copy their command, and have my local server published online. Now you can just ingress your Go apps as a net listener, something very idiomatic, very simple, very clear that they didn't just took their philosophy of how ngrok works into Go, but the other way around. They thought about how Go developers like to publish stuff on the web and just put it. And it's basically one line of like ngrok.listen, HTTP endpoint with auth token, and your Go is ingressed online. They published a Go blog post which shows like how it works and how the TLS works and how you have it in different regions in the world and stuff like that. So you can really dive into it. But I recommend just having a server and trying to run this line and seeing that it works. What other interesting Go blog posts have we seen around?
Yeah, from the official Go blog this last week, we have an article titled Code Coverage for Go Integration Tests. And this really dives into a new feature that was added in Go 1.20. If you've ever done integration tests where you actually want to test your compiled binary in Go, you may have been frustrated by the fact that you can't, at least not easily, do coverage tests of this binary. And I remember on a project several years ago doing some really ugly hacking on the test main function in my test package to kind of try to compile almost the entire binary, except for the original main function to get that test coverage. We basically, in that case, we had some tests written in CoffeeScript that were running API tests against our Go binary, and we wanted to know what kind of coverage we had. So I had to do some fancy stuff to sort of build the Go package within the test suite, and then execute this CoffeeScript by calling os.exec or something like that. And it was ugly. It worked. Thankfully, I'll never have to do that again because the Go 1.20 version adds the capability to just basically run go build with a -cover flag, and it builds the Go binary with that capability, the coverage tooling built in. And then with a simple environment variable, I can enable that while I'm executing my integration tests. So the blog post on the official Go blog really goes into the details of how this works, how you can do it. It gives an example. That's at go.dev/blog.
So I think two things. First of all, even though this show is called Cup of Go and we both canonically have our cups of coffee in our hands, we do not condone usage of CoffeeScript in this podcast. And I really hope no one has to do it ever again.
I can thankfully say we did purge all CoffeeScript from that project by the time I left.
That's great. I really imagine it felt really good, like cleaning, the head of an espresso machine and seeing all the gunk fall out and then everything flows smoothly again. So no CoffeeScript. But the real comment is, I think the combination of many features that, are talked about in Go 120 really lead to, there is some, Garden of Eden where you have a CI flow that looks like this. You build your code with all the instrumentation and everything. Instrumented for coverage, instrumented for CPU and memory profiling in production and whatever. You go lang CI lint on it and you run 100 linters in 10 seconds. So you're covered statically from the code standpoint. You run your unit tests and, they all pass. That's great. And then you run your integration tests on the next step on that binary, which is linted and whatever. And in the output, you get CPU profile, memory profile, which you can feed back into your compiler for profile guided optimization, or you can use pprof -diff base to compare to the previous version and see what increased and what decreased in the top, of the CPU runtime. And you can even do that in the test phase with benchmarks, right? And then finally, you drop it in your staging environment, which, like you said, should look as much as production as possible. And then you have coverage. You run your integration tests versus the staging environment, and you know how much of your code is covered. I think it's a pipeline that takes a while to set up, but it is very simple. Like all these steps are turn on some environment variable, turn on some build flag, and it should work, right? So it's a lot of small steps. It's not like everything comes out of the box when you have a project, but I think it's all a lot more accessible for stuff that, 5-10 years ago would have sounded like you need a full team of 10 DevOps developers to set up.
Yeah, I'm always impressed at how complete the Go ecosystem is just out of the box.
I'm wondering how else they're going to push the envelope for 121 and 122. Like, what else are we going to get out of the box next time?
Good question. Stay tuned to find out.
Yeah, exactly. And finally on our list for the news this week, if you have something cool to talk about, I think today is your last call for GoFuCon Call for Papers. Go to papercall.io. We're going to have the link in the show notes. Don't worry if it's not good enough. You have until, I think the GoFuCon is in September in San Diego. So you have until September to try it with your local Go chapter, improve it, iterate on it with your coworkers or your co-students. This is your last day. Do not procrastinate anymore. You cannot defer this execution line.
I think that wraps it up for the news this week. Thanks for listening. Stay tuned. We'll have an interview coming up with the maintainer of the package Fast HTTP, which is a popular but non-standard HTTP library for Go.
All right, and welcome to our ad break in the middle of the show. This is where you'll hear from our lovely sponsors. Oh, we don't have one yet? We're looking for sponsors. This space could be yours in all our listeners' ears. So reach out to us if you want to hire this attention span of Go developers. It's a good chance to mention how to reach us. So you can reach us at cupago.dev. We're also in the Gopher Slack. We have a channel there, hashtag cupogo with hyphens, so like kebab case. And finally, you can email us at news@cupago.dev. That is news@cupago.dev. If you like the show, or if you found it useful, leave a review on Spotify, iTunes, or wherever you listen to your podcasts. It helps out a lot to, push out the show. And if it's useful for you, maybe share it with your coworkers or your co-students or your co-gophers in your immediate vicinity. Stick around because we have a very interesting interview with Erik, the maintainer of Fast HTTP, where he is going to try and convince you not to use his library, which is a very different approach to most of the interviews we've had so far.
Hello and welcome to the exciting interview section of our show today. We have Erik Dubbelboer, if I said that right. It's a little bit of a Dutch name that I'm not very good at pronouncing. Erik and I know each other from the Golang Amsterdam meetup, where we both are heavily involved and do presentations. And I've seen him give some excellent presentations on some deep, nitty-gritty, unsafe bits of Go, which is why I'm excited about today's topic, which is the Fast HTTP package that he maintains and helps develop. But before we dive into that, Erik, would you tell us a little bit about who you are, what you do, how you use Go professionally?
Sure, I'm Erik Dubbelboer, you pronounced it almost correctly. I'm Dutch, so really Dutch last name. I'm old, I'm 39 years old already, and I've been using Go for almost since the beginning. I can't even think of how long it's been. I think since 2013, so that's already almost 10 years. Yeah. And I currently work I used to have my own company, not anymore. I work for a games company and an online advertising company, both where I use Go very actively. Not as with stuff that I used to use Go in the past, but still in a nice way that I'm very familiar with the language. Like you said, we are co-organizers of the Golang meetup in Amsterdam, which is super fun to do. Yeah. And it's still my favorite language to use.
Awesome. So the project we're talking about today is Fast HTTP. It's on github.com/valyala, I think, /Fast HTTP. Maybe you want to tell it first, what is this package? What does it do? Let's just start there.
Yeah, it's an interesting package. Fast HTTP, as the name says, it's a fast version of the net/HTTP library, but not in a drop-in kind of way. Like, it has a completely different API than net HTTP, and it promises to be faster if you use it correctly. And therein usually lies the issue.
Yes, if you use it correctly.
It's really hard to not notice that the first line on the README, we talked about this before we hit record, is, yo, back off. Just go use net HTTP unless your project really, 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 really needs, fast HTTP implementation. I'm wondering, what's the experience been with that? Like, people, quote unquote, misusing or even not needing fast HTTP. Before we dive into how it works, who is it not for? You know what I mean?
It's not for 99% of or even more of the users that just needs to do HTTP. It's really for that small percentage of users who do HTTP and need like super low consistent latencies, super fast response time, getting like 100% out of their CPU. And I can maybe tell you how I got involved with it, because that is related to it.
Yeah.
Back in 2013, 14, 15, or even a little bit after that, I was running my own company while living in Kuala Lumpur, Malaysia, where we did online advertising. And online advertising is like a really cutthroat business. So you're getting thousands of requests per second and you have to respond as quick as possible within like millisecond latencies. So at that time, I tried different languages and I ended up using Go for some reason because it was easy to develop in and still very high performant. But the issue with the standard net HTTP library is that it generates a lot of garbage. So garbage in Go, do I need to even explain that to this podcast? It's just stuff on the heap that needs to be collected by the garbage collector. And if you generate a lot of garbage, then the garbage collector is going to take longer and longer to collect it. In the past, there was much more an issue than it is these days. Garbage collector has been improved a lot over the years. But in the past, there was a big issue. So you wanted to generate the least amount of garbage, and net HTTP generates a lot. So we have fast HTTP, which doesn't generate a lot of garbage, where you can just keep reusing the memory. And that's how I started using it. Like I needed, the latency spikes with net HTTP were too big because of the stop the world garbage collector. I started using fast HTTP, but therein also lies the issue that fast HTTP reuses memory all the time. So the API to it is completely different, where sometimes you're allowed to reuse memory yourself or keep reference to objects yourself. Most of the time you're not allowed to keep reference to objects because the objects or the memory will be reused. And that is very difficult for beginners of Go, where in Go, if you have a string, it doesn't change. In fast HTTP, if you get a string back from something, it can change afterwards. Like fast HTTP does really nasty under the hood manipulations of Go structures and reuses even string memory. So strings from fast HTTP are not immutable. And that's just biting a lot of newbies in the head. And these days, like I said, the garbage collector has had a lot of improvements over the years. It's much faster now than it used to be. So for most users, this is really not an issue anymore to generate a little bit of garbage. So most of the users, I would say fast HTTP not needed. If you are running like some servers where you're getting hundreds of thousands of requests per second and you need to respond fast, like online advertising or high frequency trading or stuff, then it can be useful. If you're not doing online advertising or high frequency trading or something like that, don't use fast HTTP.
One thing that I think changed since 2015, where you had the option to, you had the problem of doing fast HTTP and then you had to figure out a way to do it correctly, was, or not correctly, but I guess really, really fast, is the introduction. The core issue is garbage collection, right? You want to do a modern language. You don't want to write stuff in C, but you have garbage collection. Today, when I'm a newbie and I'm like looking at, I have maybe a small server, edge computing, or I want to do like high frequency trading or whatever, I think a lot of reasonable people today would say, well, I'm not sure Go is the right language for me. Maybe I should go with Rust. If my issues are garbage collection and I have a really small specific use case that is kind of predictable, and I'm already at the stage where performance and garbage collection is the issue and not development velocity. Like I really know what I want to do. Like there are quite a few barriers you have to cross, I think. But I think that would be a good option as well. Where do you think fast HTTP stands today? Obviously in 2015 it was super useful, but I'm wondering if people won't prefer to just do their stuff in a non-garbage collected language at this point.
Yeah, I think so too. Like back then we had a very small development team, and we didn't have that much experience with other languages. Rust was not really that big yet. C++ was an option, looked into that, but Go just felt right for development velocity. Yeah. But if development velocity is not an issue, I would definitely go with another language these days. And I think a lot of people do. So I'm not sure how useful fast HTTP still is these days, but there's still a lot of users, so I still have to maintain it, I feel. But I'm sure there are still people who are not familiar enough with other languages to do projects like that require this. So they still choose Go and they still choose fast HTTP, which is fine.
How did you become the maintainer of this package? Because you didn't write it yourself, right? You became familiar with it as a user
Yep.
first.
So I started using it for that company, online advertising, and I ran into issues. We used it at big scale. I think at that point we were handling maybe like 50,000 requests per second on, I think it was like 4 servers. And we were running into issues, and I started to fix those issues, and I started to make pull requests on GitHub, and nothing happened. Um, no response, no nothing, and I saw that other people were also reporting issues and making pull requests for like really good changes, and nothing was happening. So I think like end of 2017, I decided to fork the project and apply my fixes, but also all the fixes from other people, all the other pull requests. I started to apply them in my own project, my own fork, and I started steering people towards my fork because that was the one that was getting maintained. And I did that for a while, and then about half a year later, Valjala, the creator of Fast HTTP, finally noticed. He already moved on to other things, I think, but he noticed and he made me a maintainer. And at that point, I started maintaining the main branch, and my fork became inactive.
Okay.
That's how I became maintainer. And since then, I've always maintained it. Every day, I think I get an email at least from someone about it. Uh, Still bugs being fixed, some features being added. I try to live by the Go backwards compatibility guidelines, so no breaking changes for current users, even though over the years there's been many instances where I would have loved to break backwards compatibility and change some APIs, because some of the APIs were not chosen in a good way. Like there could be many improvements made here. Many times I've thought about introducing fast HTTP 2 with a completely different API.
Putting my 2 cents in the jar, you have to
Yeah.
call it too fast HTTP and not fast HTTP 2.
Okay.
Just for
Yeah.
and then the next,
But
the next breaking change
I'm
will
not
be
sure if it
too
will ever be.
fast, too HTTP, too furious.
Yeah, exactly. Yeah. No, I don't think it will ever be there. Like it's no, I'm not active enough. Like to be honest, I'm still using the project myself in both companies I'm using for, but not as actively anymore as in the past. These days, the companies I'm using it with, the games company and the online advertising company, they're still doing thousands of requests per second, but the latency doesn't need to be like we don't need to respond fast, and the garbage collector got better. So the main reason I'm using it in those companies right now is to just still be using it since I'm a maintainer. Like it would be kind of stupid if I maintain a project that I'm not using myself anymore. But I don't think fast HTTP will be there. There's another big change that everyone always keeps asking for, and that is HTTP 2 support. I never looked into it. We had at least one contributor who looked into it, who tried to make a version, but it's very difficult. And I would say if you need HTTP 2, then you're better off just using the standard library.
What are some of the challenges in maintaining this?
Um, Well, one of the biggest issues is still like newbies using it
Yeah.
and generating tickets or asking questions about things where most of the time it comes down to they hold on to some memory that they shouldn't hold on to because FastHTTP reuses it and then it gets overwritten and then they're like, hey, what's happening here? But there's still some proper issues being created and contributions every week, a couple I would say, where people find actual bugs. The project is really heavily tested. We have, let me look it up, 631 tests. So that's really heavily tested. So most of the bugs are out there, I would say, but there's some code, some not so heavily used code, which still apparently has some bugs in it. The other day, for example, good example, I got an issue from someone. Someone created an issue in GitHub, and the only thing in the issue was a link to one line in the code. And I thought, like, yeah, okay, that's who creates an issue with this without describing anything, just a link to one line in the code. I was like, okay, I'm just gonna close that. But I looked at that one line, and it was immediately obvious that it was a bug. It was a statement like assign something to a variable with and then an error, like the normal, like if this comma error is something. And then if there was an error, it would initialize some struct and then assign a new variable instead of that same variable that was supposed to be. Like, it was a super stupid bug, but I that's what I fixed. We've also had other issues with codes where it's just not tested very often. There's some extra packages within the library, like for proxy, for example, or SOX proxy authentication, things like that, which haven't been tested very well, where we get issues. But yeah, most of the things are fixed quite easily. There's definitely some very active contributors at the moment. Well, there've always been, and they also fix a lot of issues. Like we also still get issues that are pull requests that fix spelling errors in documentation, for example.
Yeah.
Sure, that always happens. But also like very good stuff where someone adds new functionality or fixes some really minor issues. I think per week I spend maybe 1 or 2 hours going through all those issues and pull requests. Pull requests, I usually have to make a couple of suggestions to get them really ready to merge. And I always ask someone, I want a test case in the pull request. I want a test that fails before the changes and passes after, which I guess makes sense. So that's why we also have a lot of tests in there now. And overall, like, the maintaining it is very, very nice. Like, there's not because it's the project it doesn't have any like really big changes in the last year, so there's no really big bugs. So I haven't seen any issue recently where I would like really need hours and hours to find the solution or find the bug. So overall, it's a nice project to maintain.
I see that you have a release, I don't know, the most recent one was in January, and then before that, November, a couple November. So every few months, it looks like a release. Is there any particular cadence on that, or it's just whenever something important comes along, or how do you decide when to release again?
There is, I don't have like a fixed release schedule or something like that. Like once in a while, I'm thinking there's been a couple of merges of some like minor bugs that have been fixed. Okay, maybe I should do a release now. Or if there was like a big bug, which happens like maybe once a year, then afterwards I do a release. Just a couple days ago, I was thinking there's been quite a bit of merges now. I should probably do a release again. Then I'll probably do a release this week, and I usually do it in Dutch time somewhere in the afternoon in the start of the week. Like, I don't want to release anything in a weekend or on a Friday or something like that. Like, you don't know who is automatically pulling in the latest version in their CI and deploying it for some reason. Like, you want to release if something goes wrong for someone, that they can fix it, that they're in their office.
Right.
One thing I wanted to ask is about arranging the meetups in, other than maintaining a library, also maintaining a community. Seems like you reach out to really quite a lot of people who do Go. And we've had a lot of, we talked with some, community organizers. Obviously, Jonathan is one of them. And we also had Miki here on the show, which is, I guess, your equivalent here in Israel. What do you find? Because obviously it's not easy to arrange these meetups, and I guess the hardest part always is to find lecturers and good talks. What keeps you in that loop? What do you like doing it?
Good question. Yeah, I like doing it because I like the meetups. Like it's fun to go to them, talk to people, talk about Go, not just about Go, but I like developer life in general, I would say. And it's not always easy to do the meetups. Like you really have to make time for it, and you really have to force yourself once in a while to put some time into it. But it's just fun to do. Like I would recommend everyone to try and organize a meetup.
Do you own stock in meetup.com?
Ooh. I'm glad I don't own stock in meetup.com. Like, no, thank you. That hasn't always been working the best, to be honest. But it's nice to organize a meetup. I would say it's less difficult than people think it is. Like you just have to find a venue, you have to talk to some speakers, get them, and then bring that together somehow. Just improvise.
And another question I was interested in your current companies, and also in your hobby project, you seem to be doing game development, which is something I really don't see a lot of gophers doing. Do you incorporate Go in your game development, or do you use C# Unity or C++ Unreal?
No, I did a little bit Unreal, but I'm working for one of the companies I'm working for is a games company. We have a portal, Poki.com, which is HTML5 games. So right now I'm mostly into creating HTML5 games as well. I don't use Go for that at all. Like if I need a backend for a game, I would use Go for the backend, but no, I haven't used, I think there are some libraries for it, but I haven't tried using Go in such a way, mainly because in HTML5 game development, loading time is everything. So if your user doesn't get to play your game within a couple of seconds, they will just go play another game. Users are really not invested into it. And if you build a game, JavaScript game in Go, like if you do a WASM binary, that's always going to be a lot bigger than if you write it natively in JavaScript.
Interesting. Well, maybe your next open source library, you know what I mean? Fast game dev.
Yeah, who knows?
So every guest on the show here, every gopher on the show gets a pretty difficult question. So I hope you're ready. The question is, you have to. There's no option not to. You have to delete a feature from Go. One feature that you don't like, or a library, or a language feature, or something you don't like about Go. What are you killing off?
What am I killing off? Ooh, that is a difficult question. I'm thinking maybe some part I don't use. Like my first thought would be, I haven't really actively used generics yet. Can I delete that? But maybe at some point I want to start using it more. What else is there in Go that's yeah. Poo. Can my answer be, I want to kill that line that is allowed between the function definition and the body?
Yeah.
Like, when you have a function and then a new line and then the body, the code starts, that new line I want to delete. I still don't understand why that is allowed in Go thumped.
I like Go thumped with the U because it doesn't do that.
Yeah? Okay.
The other is a flip version of that. If you could add a feature to Go, what would it be?
If I could add... Ooh. I sometimes see those threads pop up on Reddit as well, and I think one of the top answers is always enums.
Yes.
I wouldn't mind having enums. I sometimes run into that issue. Like just last week, we had an issue in a library we're building where we swapped around two arguments to a function because they were both strings, and we didn't If they were enums, we would, with like type safety, we wouldn't have noticed that. But now we didn't, so we swapped them around accidentally, and that resulted in a bug that took us a long time to find out. Yeah, I'll go with enums.
That's a good answer.
Let's do it.
There are two patterns that I can recommend personally from what we're doing at Rico right now to resolve these issues. One, if you have a string that is more than a string, let's say it's a user ID, just type def string user ID and put it all over the code. It's a lot easier to read. And two, you can take the extreme, super, super, super extreme route that I went with and just force the entire company to use protobuf just for the enums. Which is very extreme, but I can from personal experience say it works.
Okay.
People might hate you, but it works.
Extreme. Typing the strings that's a good solution. That's true.
Well, thanks, Erik, for coming on and talking about fast HTTP. We'll, of course, have a link in the show notes for anybody who's in that 0.01% of people who it's really written for who want to go look at it. Or if you're just interested, of course, you can still check it out. Any last words you'd like to add before we sign off?
No, thank you for having me on the podcast.
Great. Thanks for coming.
Thanks a lot, Erik. All right, so Erik's off the recording here. We forgot to mention one thing we did when the cameras weren't running. That Go fuzzing, and fuzzing in general, has been a huge thing in fast HTTP as well. He mentioned how the Chrome team fuzzed it, and in general that there's a lot of fuzzing done on the library, and he had some talks about it and whatever. You didn't get a chance to play around with fuzzing yet, right, Jonathan?
No, it's been on my radar since it was released or even before, but I haven't played with it yet. It's something I need to do.
You have to, man. It's so much fun. You just feel so smart. You don't do anything. You type the word fuzz and suddenly you're a genius. You're a researcher. So if you want to find Erik, all his contact details are on his GitHub page. The page is going to be in the show notes. But you can find his LinkedIn and Crunchbase and the companies he works for, the Golang meetup he organizes in Amsterdam, and his email, all in his GitHub page, including his numerous contributions. So thanks a lot, Erik. This is going to do it for this episode of Cup of Go. My coffee cup is getting colder.
Mine too.
I'll finish it off. All right. See y'all next week.
See you next week.
Bye.